8, 7. There's the lines, you can see it. 9, 12, and 18. So on number 9, 4.008 repeating. So it's an infinite series. Find the constant ratio of R if it's geometric. State whether the series is convergent. If the series is convergent, give its sum. So I'm going to give the answer first just so we know where we're going, and then maybe that'll help you connect the dots too. So this is not geometric, which I'll show you why in a sec. It is convergent though, and it will converge to 902 over 225. This is weird because it uses decimals, and so you always want to go back to the decimal form. So you have to make sure you know what your end goal really is so you're not stuck somewhere. So decimals, you always pronounce the decimal as an and. So this is 4 and tenths, hundredths, 8 thousandths, and then this keeps going. So it's not just 8 thousandths, it's everything. So this is 4 and this is thousandths, so I get 8 thousandths plus 8 ten thousandths plus 8 100 thousandths plus 8 1 millionths, dot, dot, dot. You get the idea, right? Okay, so this isn't geometric because this 4 ruins it. This is all geometric with a common ratio of, you multiplied by 10, so 1/10, because that makes sense, we're base 10. So the common ratio would be 1/10, but that 4 ruins it. So it's not actually, this whole thing is not geometric. But I can use the fact that in this section, R is 1/10 to help me. So I have 4 plus the summation, we'll just start with I equals 1, this goes to infinity, of these numbers. So I'm adding up a sequence. Adding up a sequence is the series, but I need to look at this like a sequence and go back to my 8-2 formulas of how I write an explicit geometric sequence. So an explicit geometric sequence takes my first value, which in this case is 8 1,000ths. I'm going to multiply it by the ratio to n minus 1. Okay? So this is another way of writing out my original decimal. And it wants to know what it converges to. So this is an infinite geometric series. This part is. The whole thing is not geometric, but this part is, so I can use that to my advantage. So I know this part is going to add up to g sub 1 over 1 minus r because, what's my ratio? 1/10. Is that between -1 and 1? Yes. So I can write, it's going to converge to the first term, which is 8 thousandths over 1 minus 1/10. And I'm going to plug this in my calculator. Since I'm dealing with fractions, I am going to keep my fractions. Divide by, in parentheses, 9/10, and math frac, enter. This is 2 over 225. So, excuse me, that's what this extra 8 over all the zeros and ones are. This then it means it converges to 4 plus 2 over 225. You'll see why I'm not using decimals in a sec. So I'm going to convert this into having common denominators. So I'm going to multiply by 225 over 225. 4 times 225 is 900. So this is 900 over 225 plus 2 over 225. That means this whole decimal, 4.0888888, does converge because it actually is a single fraction. It's not geometric because that 4 throws it all off, and it converges to that fraction, which we did just fine. Now, if you take 902 in your calculator, 902 and divide by 225, what do you think you're going to get? Yeah, that 9 is just because it rounds up because it's an infinite. So you can't use decimals because you're trying to move the decimals into a fractional form. If you go back and use decimals, you'll act like you're lost because you are lost because you're not in the right form. So watch fractions. All right, so that was number 9, and then I need to do 12 and 18. Okay. 12. Consider the sequence. This is recursive or is it explicit? It is recursive because it recalls a previous term. Again, I don't care if you have this 4 and greater than 1. It's nice. If you put it, make sure you're accurate, because if you put it incorrectly, then I will take off points, but you don't have to have it. I'm not going to be picky about it. All right, is the sequence arithmetic, geometric, or neither? Since this is a ratio, this would be geometric. Explain because r equals 2/5. Yeah. Yeah. B, because this is recursive, that's how you write recursive ones. Does the sequence T converge? Since r is r between this range. Yes, so it will converge. And then if so, give its limit. So the limit as n goes to infinity of t sub n is going 12b c margin. Okay, right. So, I guess there's no real great way to do it mathematically. I just write it out as a list. So you start with 40. 2/5 of 40. A fifth is 8. 2/5 would be 16. Okay. And then 2/5 is 0.4. So 0.4 times 16 is 5.6. Times 0.4 would be 2.24. So you can look at it as decimals if you want, or look at it as fractions. Fractions might tell you more, because 5.6 would be 28/5. This would then be 48/25. And then this would be times 2, so that'd be 96 over 125. So you would notice, as you keep going, what do you think we're going to get closer to? 0, because my denominator keeps getting bigger, and the gap between, like this is a nice whole number. It's 5 wholes. This is still 2 wholes, but is this a whole number at all? No, there's no whole part. It's all just the remainder, 96 out of 125. So the limit is going to be 0. And then C, does the limit of the infinite series? So what if I added all of these up going for infinity? If I add all of those up, does it converge? That's actually what this is for. This still helps you with the sequence, but this would be for the series. Since it is a yes, then I'm going to know that in the end it's going to add up to 2/5. 1 over, oh, that's not the first term. The first term is 40 minus 2/5, because that's my first term over 1 minus r. My r is 2/5 because it's in between my -1 and +1. So I'm going to do this by hand so you can see the math. Over 3/5. 40 divided by a fraction is the same as saying 40 times the reciprocal, 5/3. That would be 200 over 3. So it will converge to 200 thirds. That was 12, and my last one is 18. All right. 18, all of my work was on the homework. If you looked at the key, I did write down all the fractions, fractions and all the equations, but the main thing is you're given s equals p plus 2p squared plus 3p cubed plus 4p to the 4th, and we know p is between our range that we like, -1 and 1. We know it's either a fraction or 0. This is awesome because we know what those kind of series then will sum up to, or converge to. And it wants to know, find the sum of the series. So we are finding s infinity. And they want us to look at s minus sp. That's their hint. So let's see what that looks like. So copying down s. That's my s. Now I'm going to subtract s times p. So minus, again in parentheses, s times p. So my first one, p, well, times another p is actually p squared. 2p squared times another p is 2p cubed, and then that'll give us 3p to the 4th plus 4p to the 5th, all the way up, okay? Now let's look and see what we can do with this. This negative gets distributed to everything in that second set. So now I'm going to be getting p minus, there's no like terms over there, so that's just p. 2p squared minus p squared, okay? And there's no other squares anywhere else. Those are the only two squared terms I have. 2p squared minus p squared, that's just 1p squared, okay? 3p squared minus 2p squared, or cubed. 3p cubed minus 2p cubed. They're the only p cubes we have, cubed p's. So I get plus p cubed, plus p to the fourth, plus p to the fifth, plus da-da-da-da. Now we have this. Is this a sequence or a series? It's the series because I'm adding them all together. Is it arithmetic or geometric? It's geometric because what's the common ratio? P. So I know that S minus SP in the long term will sum, this whole sum is going to be the first term divided by 1 minus the rate. And since we know the rate is between our magical interval, it's not magical, it's just really convenient, I know I can write it like this. So this whole summation turns into this. Now they wanted us to sum just S. What is S? So I'm going to move this S minus P. Wait, this is S times P. S times P. Okay. Right, so both of these have what in common? S. So I can factor out the S. So I get 1 minus P equals P times 1 minus P. Okay, I like S by itself, so I'm going to divide by 1 minus P. Divide by 1 minus P is the same thing as multiplying by the reciprocal. Those make 1. So S will add up to P over 1 minus P squared. Okay, if you have something like this on your test, please show work. Some people in their homework just put the answer or something like the answer but wasn't quite right. And I was like, without the work, you're not backing yourself up. It may ask only what this answer is, but to prove you actually did it and didn't just look it up, please show me work.